So simplifying radicals, remember a radical is the what you are used to calling a square root. And then this number right here, I actually looked it up and it's called an index number. So it's just the third root or 3 square root of 54. So you will hear it called something different a few times. So if you look, it's the third root of 54. Remember, just like a square root, the third root of a 54. That means what number times itself 3 times gives you 54. Most people can't just look at 54 and decide what is multiplying in there. And it's not actually a perfect number. We're going to have something left over. So I'm going to get my calculator. One of the easiest ways that I feel doing this is to write out what's called a factor tree. So I'm going to take 54 and I'm just going to start dividing. Well, I know 54 is an even number, so I'm going to divide it by 2. So 54 divided by 2 is 2 and 27. So I'm going to put the factors. So 2 and 27 go into 54. And then I'm going to do it again. Well, 2 is just 2 and 1. We don't need to list 1 as a factor because 1 can go into any number. So then I'm going to take 27. Well, 2 doesn't go into 27, and then let's try 3. So 27 divided by 3 is 9. And then when you look at 9, if you can't, hopefully you can easily see that 9 is 3 times 3, or you could also take 9 and divide again. The bottoms of these trees are the actual things that are the numbers that multiply into 54. So if I took 2 times 3 times 3 times 3, it should give you 54. So the bottom of each of those little, what we call trees. Remember we were talking about that it's the third root of 54. So you're looking for what number times itself 3 times gives you 54. So we definitely know that 2 is not repeated. 2 is by itself, or there's no repeated 2, I should say. And then we have a 3, a 3, and a 3. I'm going to circle those. So since though the 3 is multiplying times itself 3 times, it is, or 3 times 3 times 3, 3 times 3 times 3 is that 27. So if I were to take the cube root, remember hit math, and then go down to the number 4. So take the cube root of 27. It's 3, because 3 times itself 3 times is 27. So you can write, and I'm going to write this in 2 different ways. So I'm going to say 3 cubed and then times 2. Remember 3 cubed is 27, times 2 gave us the 54. And then you can remember that 3, or the third root of 3 cubed, times the third root of 2. And then remember, just like a square root and a squared cancel out, I can say that both of those cancel out. And then if you look, the third root of 2, 2 is by itself on this factor tree. Even if there was a second 2, it couldn't cancel out because it's that 3, or that index tells you that you need 3 of them. So then it would be 3 times the cube root of 2. And just like when we're talking about, just when we're talking about multiplying numbers and variables, you don't even have to write the multiply. You could say 3 cube root of 2 is the simplified answer, because 3 times 3 times 3 was 27, and 27 times 2 gave you 54. Alright, so the next example, let's do one with variables. So remember, the index doesn't always have to be a 3. This time let's do a 4. So let's do 4y to the 9th. So remember, y to the 9th means I have 9 y's multiplying. So I could rewrite it as, I'm going to write the fourth root of y 1, 2, 3, 4, 5, 6, 7, 8, 9. And then since it says the fourth root, I'm looking for something times itself 4 times. So I have 1, 2, 3, 4, 1, 2, 3, 4. And just like when we were talking about these 3's on the factors up here, you could write a factor tree out, but these are all the factors, just multiplying times itself. So this is a y, and what I pull out is a y, or I could rewrite it as y to the fourth, or the fourth root of y to the fourth, times the fourth root of y to the fourth, and then times the fourth root of y. So I just rewrote this right there, and that right there. So the fourth root of y to the fourth times the fourth root of y to the fourth times the fourth root of y. So I'm just taking each of those sets and rewriting them as many times as I can as y to the fourth, and then there's just a leftover y. Now remember, when you are looking at square roots or cube roots like we did right there, I can cancel a fourth root and a 4, a fourth root and a 4, and so then we're left with the fourth root of y. So we have y times the fourth root of y. So we have 2 sets of y's that pulled out, which means I have y squared and the fourth root of y. That would be my final answer. Something that the way I've explained it in the past is we're looking for sets of 4. So I pulled out 1 set of 4 and a second set of 4. So you could say you pulled out y squared and then the fourth root of y. Either way, it's the same thing. I just think that since you guys are more used to canceling out square roots and squareds, then this makes a little bit more sense. Alright, so now let's combine numbers and variables together. So if we have the fourth root of 16, x to the third, y to the fifth. So first thing I'm going to do is do my factor tree for 16. So I'm going to say 16 and then do my factors. You can divide it if you need to, or I know that 16 is 2 times 8. I know that 8 is 2 times 4, and I know that 4 is 2 times 2. The ends of my factors are 2 times 2 times 2 times 2. Well, if you look at that, there are 4 of them. Remember, this fourth root right here tells me I am looking for 4 of them multiplying. So I'm going to rewrite this as the fourth root, and I'm going to put 2 times 2 times 2 times 2. And then if we look at the x cubed, it's going to be x times x times x. And then if we look at the y to the fifth, it's y 1, 2, 3, 4, 5 times. Extend that. Okay, remember we are looking for sets of 4. So we have 2 to the fourth. We only have 3 there. So since I don't have 4 of them, I'm not going to write it as x to the fourth, or since it's not x to the fourth, nothing's going to cancel, but we can still look at it as x cubed. And then we need it as y to the fourth, and then times y. So again, we're looking for sets of 4. Just like I had a leftover y here, or a remaining y there, I have a remaining y here. So then again, you can take that fourth root and I can write it as the fourth root of 2 to the fourth. I can write it as a fourth root of x to the third, a fourth root of y to the fourth, and a fourth root of just y. Sorry, that's a 4 right there. Okay, you're looking for where they cancel, so I know that I can cancel a 4 and a 4 there, a fourth root and a 4. Notice this is a 4 and this is a 3. I cannot cancel. So you can only cancel a fourth root with a 4. So that one has to stay the same. This one is a fourth root and a 4. And this is a little bit hard to see just because of the numbers. Notice that and that canceled, so we're left with 2. This one is still under the fourth root, so that one needs to stay under the fourth root. So we have x cubed still under there. And then this y canceled, and then there's a y still remaining. So again, like I was talking about up before, we have a set of 2's that could come out, and we have a set of y's. The x cubed and the y that are right there still stay inside of the fourth root. So that's my final answer. It's just a little spread out because of how I wrote it. So we have 2 times y, and then the fourth root of x cubed y. So 16 is 2 times 2 times 2 times 2. And then the y and the x cubed stay inside because there was not 4 of them. There were 4 here, but there was a remaining one. Okay, and then our last example, so whenever we look at them in a fraction. So if we have a fifth root, so again, since this one is now a 5, we're going to be looking for 5 of the 5 multiplying times itself, or something multiplying times itself 5 times. So we're going to do 4 divided by 2, x to the 7th, y, and then x squared. Okay, now if you look at that, I personally think it's easier to simplify everything inside first. Just not think, but you should simplify everything inside of the radical or under the radical, just like we have to simplify inside of a parentheses first. So if we think about 4 divided by 2, this is stuff that we've been doing recently. 4 divided by 2 is just 2, or 2 over 1. Then if we have x to the 7th divided by x squared, if you remember our rules, x to the 7th divided by x squared, you would do 7 minus 2, which would make that one cancel and would leave that as a 5. Or if you still are having to write them out, even though you should really be working on remembering the rules, 1, 2, 3, 4, then you would have 7 on top and 2 on bottom, and you can cancel 2 sets. And you would have 1, 2, 3, 4, 5, so x to the 5th remaining. So now if we rewrite that, it would be the 5th root of 2. There is nothing left on bottom, so I don't actually need to write the division bar, or there's nothing left in the denominator, it's all in the numerator. So I need to do 2x to the 5th y, and then we will cancel it. So to simplify this, again, we're going to look at what number or variable times itself 5 times. So again, I'm going to rewrite it. So the 5th root, and I'm going to expand each of these out. Well, 2, if we do a factor tree, the only thing that multiplies to get 2 is 2 and 1. So that can't simplify any, so it's just going to be written as a 2. X to the 5th can be written as, hold on, I gotta find my whiteout. Okay, so I forgot to stretch these out. So then I'm going to do times the 5th root of x. Now notice this one's already written as 5, so 1, 2, 3, 4, 5, if you look over here. Well, we're looking for 5 of them, So I'm going to leave it written as 5 square root of x to the 5th, or the 5th root of x to the 5th, and then I'm going to write it as the 5th root of y. The only one of those that can cancel the radical and the exponent is this one and this one. So that would come out. So this would come out in front. So I'm left with just x. Notice the 2 and the y are still underneath the radical, or the 5th root. So I'm going to write it as the 5th root. My blue pen has stopped working. And then 2y are still inside. So if you look right here, the 2 and the y still stay inside, and then the x comes out front. You can expand this out, and then you can rewrite it combined back together. For me personally, that just makes more sense, just because I can get rid of the 5th root and the exponent of 5 separately, and then think about what stayed inside of the radical. So that is simplifying radicals.